Okay, so I propose then we head into our next session dedicating to the licensing and safety aspects. And our presenter for this session is Jan Meulenbrugge from Energy. Over to you, Jan.
Thank you very much, Jessica. It works now? Okay. First, I'd like to thank the previous speakers, since I think especially Martin and Stephanie gave very interesting presentations. And this is always a bit more dull topic, licensing. I try to keep it interesting for you, but that might be a bit challenging. This is Jeanette showed you all the work packages. Now we're focusing on the licensing roadmap. This is the content of my presentation. First, some general context at EU level, the regulatory framework that we looked in for both nuclear and hydrogen. A bit more details on the safety aspects, which is, of course, an important aspect, as Martin and Stephanie also already showed. Then we have a kind of overview for stakeholders with all the aspects that play a role when starting a discussion on building or constructing an HPP, and then some final conclusions. Maybe just to pay a bit more attention to the challenge that we have at the moment, or this was in 2023, the production of hydrogen is about 10,000 kilotons, so 10 megatons. The challenge that is set by the EU is that we want to have 10 megatons of renewable hydrogen by 2030. At the moment, that's only 46 kilotons, so it has to be multiplied by a factor of more than 200. That's quite a challenge. Another challenge is, and that was already mentioned in the previous presentation, that pink carbon is not yet acknowledged as a low carbon energy source. So there needs to be some work done there. At European level, we understand they are working on a complete licensing framework where they set regulations and guidelines for production, consumption, infrastructure, and all aspects. That is being worked on, but it is not there yet. And as was said before, that is a prerequisite for getting this started. Of course, there is already licensing framework present. Hydrogen itself, there's not a specific legal framework for hydrogen. It is considered as a dangerous chemical material and therefore falls under the SAFESO directive with all kind of regulations and guidelines how to deal with it, and especially how to show that it is safe. Co-generation with an NPP is in principle possible. So there is no objection, whatever, but it needs approval by the authorities. So an NPP, in the license of an NPP, all activities that are allowed by an NPP are mentioned explicitly. Very often, hydrogen production is not mentioned as an explicit activity that is allowed by the license. So if you want to couple it, the NPP license has to be changed a bit, or at least needs approval from the authorities. Looking at coupling of an HPP with an NPP, there are two main aspects that determine the licensing process, and that is whether you do it offsite or onsite, the NPP. When you do it offsite, then you don't have much interference with the nuclear license and all the regulations concerning that. But then there still are many topics that you have to deal with. First, the site location, of course, environmental impact, safety aspects of the HPP itself, but that's covered with by the Seveso directive, and there are many other things that you have to pay attention to. When you do it on site, the site selection is much easier. You don't have much work there. Probably you can also rely a bit upon the environmental impact assessment of the MPP, since the APP will not add much to that, so that will be a limited scope. The same for other side of industrial emissions. An additional effort, however, when you go on the MPP side is, of course, that you create some additional risk to the MPP. And that's depending on the distance between the two installations and the systems you share. It can be a significant portion of the work. The rest will be more or less the same. And since you introduce something on the nuclear power plant side, the HPP is in most cases considered to be part of the nuclear site, so you need to update the license. When you couple the two, so the previous slide was more if you put it on site, but there's no real sharing of systems. And I can go through this quickly, since I think Martin mentioned it already. When you couple and share systems, you really have to look in the modification of the systems, especially on the nuclear side, and you need to really show that the safety is not compromised in any way, and all kind of documentation needs to be updated. That is one of the main reasons, I think, that nuclear power plants are reluctant in sharing systems that are an essential part of their installations, like the steam, since that will have quite some safety implications. This is a bit in a graph, the presentation of what I just said. The upper side is when you just connect the HPP to the NPP by the grid or by an electrical connection, but it's offsite. You mainly have to deal with the hydrogen licensing aspects. You can do it on site, then you combine the then you have activities on hydrogen and nuclear, and for the combined installations. But when you start for integration, and the more you integrate and the more safety-related systems you integrate, the more the nuclear license becomes important, of course. Safety, yeah, is an important aspect, as you know. I think most of you know that hydrogen is a highly flammable and explosive compound, so that is the main hazard when you want to construct an installation close to other installations, and especially in NPP. When you look a bit more in detail, what are the actual scenarios where things can go wrong and can create the real hazard? I'll start at the bottom. Of course, there can be a failure of the installation, a mechanical failure. So you get a hydrogen leakage. It can be small or larger, and it can be released in the open. When you get immediate ignition, you get a jet fire. And if you get a delayed ignition, then a cloud is being formed, and you can get a vapor cloud explosion. If it's in an unconfined area, that's not the most hazardous situation, since hydrogen is very light and tends to go up, so you don't get high concentrations on ground level, and so it disperses relatively easy. That's not the case when you have a confined, you're in the confined space, then real concentration can be built up. If you have, in the same situation, if there is a leakage, you have immediate ignition, you get a jet fire, but delayed ignition can be more severe since you can build up concentration and you get a vapor cloud explosion. But what turned out to be the most severe situation and the most severe hazard from a hydrogen installation is if you have storage of hydrogen in high pressure vessels. Especially when you have an external fire and those vessels are exposed to the heat, you get buildup of pressure, and the storage vessels already are at pressure levels 300 bars, 500 bars, even up to 700 bars. And if they are heated, pressure builds up further. The vessel will burst. That first will give fragments that have already significant impact, but especially at that moment, all content of hydrogen is being released at the same time, giving an enormous vapor cloud explosion. And that turns out to be the most severe accident with the highest safety distances. I'll show you. First, the fragments. Since if you have those tubes with high pressures of hydrogen and the vessel bursts, parts of the tube can be propelled over long distances, and that turns out to be up to even more than 500 meters. That's already a significant distance. The impact of that, of course, can be significant, but there are only a limited number of fragments, so it should be possible to deal with that. But the vapor cloud explosion of all the hydrogen being released at that moment is even much more severe. But of course, that depends on the amount of hydrogen that is present in those storage vessels. When you look at the hydrogen electrolyzer facility itself, there's a limited amount of hydrogen present, and there the distance is about 150 meters. But if you have a storage in the order of 1 day production that we were talking about, the 30 megawatt produces about 12,000 kilograms per day, then you have distances of more than a kilometer. So for safety reasons, you really have to take care where you place the hydrogen storage. And Martin mentioned it already, that is preferably outside the NPP site, but at least at the distance larger than the safety distances. And indirectly, a pipeline transport where you can discharge all your hydrogen immediately and you don't need the storage is to be preferred, since then you have much less problems with safety distances and also related licensing issues. We made an estimate, and this is very indicative since it is site specific, it is country specific, but an indication of the timeline when you go for hydrogen production, how long it would take. And it depends. If you have a site where it is already allowed to construct something like a hydrogen production plant, so if you don't have issues with siting, you can start the licensing process, then our estimate is that would take at the minimum, so the optimal case, about 1.5 years. Then you have the construction time of the HPP, I don't know exactly what that is. That will also depend upon all kind of situations, but say that's also around 1.5 years. So at the minimum, you need 3 years. But in practice, things will be more complicated, especially when you have issues with the land use plan. If you need to do an extensive environmental impact assessment, and especially if there is a pipeline involved and there is no pipeline available and you want to construct one, you have to find a trajectory and everything that has to deal with that. It's a time-consuming activity. And then the licensing work can last easily 3-4 years or maybe even more, depending upon all kind of situations. So in that case, the finalization of the HPP would be at least 7 years from the starting point. Initially, in this work package, we had the idea that we could design a kind of optimal licensing route that appeared to be not possible. There are so many situations and configurations possible, and especially also for the various countries that can be all different. But we had the feeling that we could create an overview of stakeholders that are involved in the decision process of all the factors that are involved in how such a process maybe could look like, how to come to a decision on whether to build an HPP or not, connected to an MPP. We created this picture, and I'll explain it in a bit more detail. You start on the top, more or less. There should be somehow an incentive to invest in the HPP in combination with an either existing or new MPP. The first check, if you have as an MPP owner, is of course, does that fit within my mission? Do we want this? Are there any legal or financial constraints that allow us or prevent us from doing so? If that's a yes, you go more into the market side. And of course, Cecilia will tell you much more about that in detail this afternoon. But then you look at what is the electricity price, at what price could we maybe produce hydrogen? Are there any governmental regulations that support doing so? If that's positive, there's the next step. The internal economic drivers, you have to look at the size of the MPP, the HPP that you need, and all kind of technical inputs. And then you end up in the center of also our NPHyCo project. But in this decision making is, and you need to assess the economic performance. And I don't go into detail there, but if you have the first 3 steps are positive, you can start that process, selecting a technology, looking at the specific scenarios from integration, but also operation. And that is a loop that you have to go through several times, and then there should come out an optimal configuration. The size of the HPP, the type of technology, at what level do you want to integrate with the MPP, operational issues, and so forth. And if that's positive, if that can be profitable, of course, then you can start the process. This is a very generic overview. I think it sounds very logical for people who are involved in more detail, but we had the feeling that it could help people who start the discussion, that there are many factors that play a role, and there are many steps that you have to set before you can come to a final decision on whether to invest in an HPP or not. that, oh, this is a bit larger version. I thought it might be too small. Conclusions. First, safety and also technical issues and licensing issues are no showstoppers. It was already said before, but that allows the coupling of an HPP to an MPP. The main determining criterion of factors are the economical factors. Shared systems may or will probably complicate the licensing process and prolong also the licensing process, depending upon whether it are auxiliary systems that and that don't have any impact on safety, then the impact will not be so long. But for safety-related systems, that might be significant. But of course, they could create some financial benefits. That has to be sorted out in detail. And as I already said, a large storage of hydrogen will create large safety distances. And that is something you do not want. That will complicate siting and complicate licensing. And so solutions where you can minimize the storage amounts are preferred, at least from a safety and licensing point of view. That's, I think, what concludes my presentation. Thank you.
Thank you very much, Jan. And if we could now put the screen up so we can also see everybody online. As with the previous session, for those of you who are online, please don't hesitate to raise your hand if you have a question to Jan. But maybe if I turn first of all to the room, does anyone have any questions for Jan or any comments in terms of what he has just presented? Can you put the Teams thing up, just in case? Yes.
I'm sure there will be other questions. I'm just trying just to kick off. Thanks, Jan, for the presentation. It's very interesting to hear from you saying that long distances will bring longer safety requirements. So in the case of low temperature electrolyzers, actually, we don't have to be close to nuclear power plants, and then we can extract get the electricity from the grid next door to the end users, and we can install the hydrogen island close to, I don't know, the end users. So this is a very classic setup of a renewable hydrogen project. So there is no safety related to nuclear in this case.
Yeah.
How can you comment this or clarify?
Yeah, it's. I think it's completely true what you say. The challenge for the coupling of hydrogen to nuclear, or the biggest opportunities will be in cases where the nuclear power plant is not too far from potential off-takers. I think that's not only for the heat. It's probably also when you want to deliver direct electricity, so at not via the grid, then you also do not want to have a large distance between the two. And that's also from an economical point of view more interesting than delivery via the grid. At least that's what I understood. But I think Cecilia can. Yeah. Yeah. And but for the transportation cost, and that was already shown earlier this morning, it's very clear that transportation cost is a significant portion of the total hydrogen delivery cost, and therefore these should be minimized. But if there is an existing pipeline present that you can easily connect to, then that's probably a rather cheap option. And then the distance is not so critical.
interesting one would have been Borsele, for example, because that's in the Schelde region where you have Shell and Exxon and all of that, and they are the consumers and they are interested in green hydrogen currently. Unfortunately, they decided not to build it close to Borsele nuclear power plant, but offshore wind energy instead. But maybe we can have both instead of only one. That would be a good location from my point of view.
Thank you, Jan, for the presentation. Just a question about the duration of the licensing that you mentioned, that it takes at least 3-4 years to update the nuclear license. And in view of the new commission, new work plan now that they want to do, fast, agile Europe and cut all the red tape, just from that point of view, I mean, are those two related? So is there any red tape to cut, or is it just such a complex topic that it will just take 3-4 years? It's inevitable, or is there something to be done in terms of being able to shorten that process?
I think it is not easy to bring those times down and to make them shorter. It has to do with the attitude that all regulators have, that you really have to show in detail that things are safe. So you need a really detailed design first to make, and then you have to evaluate it. Then you can start a discussion with the regulator. They often have questions, and also the judgment of what you propose takes time, and that whole process is quite time consuming. And I think there's not an easy way out from the current situation.
Is there a question online? No, I don't see any hands raised. In any case, we will be making the recording of the event available to everybody. We will also be sharing all the slides. If you do have additional questions that come up after the event, please don't hesitate to send them in to us, and we will pass them on to the relevant people in the project. But we have one question here.
Thank you. I was wondering if you could dive a bit deeper into the distances. There was a table with a safe distance, and I had the feeling that sometimes that the objective was not always the same. In some cases, it was to protect the electrolyzer. Was there any case in which the protection was at the level of the installation of the nuclear installation?
Oh yes, there was. Can you put the screen back to?
And I'm asking the question, just the background while it takes the slides up, because nuclear installations are often built to withstand very severe external accidental hazards. So we did some rough calculations in the past, and it seemed to be quite like the safe distance was quite smaller actually what you're showing here.
It can be here the criteria were taken, so a 10 kilopascal overpressure at a certain distance, and with another model it was there 5 kilopascal were used, and the highest distances were these distances. I think the nuclear dome, so the nuclear island itself, can easily withstand pressures of 10 kilodome. So the nuclear island itself will not be damaged. But there are many buildings around it with all kinds of supporting systems that can still be damaged. And that's not what you want. That will not maybe initiate a nuclear incident, but it will shut down the reactor and you have a lot of damage. So normal buildings, there the 10 kilopascal is the standard norm that constructions can withstand, and higher, it depends on how it is built.
Great. Well, thank you very much, Jan. I propose now we head over to lunch, because the afternoon will be kicking off with a very important session dedicated to the economic case and the business case. So we'll stop now, but if I can invite everybody to be back in the room and connected online from 1:30. That would be great. And for those here on site, please follow me and I will guide you downstairs for lunch. Thank you.